Hello, good morning. Where are we at? Here we are. Okay, lost the stream a couple of days now. It's just insane having a 4-year-old and a 4 months, well, soon 5-month-year-old. It's so exhausting. It's crazy. So please thank your parents for just they probably forgot this. Like if you go to your parents now and you say thanks for sticking to it when I was a baby, I know it was rough, they'll probably say, oh, what are you talking about? It was just a joy having you as a baby, because we suppress this stuff. We suppress it, and I will as well. But now I've actually documented it. So when I get older, I'll get back to the stream and I'll listen to myself talk about how insanely exhausting it is to have kids. That small, at least. Anyways, we are going to... Oh. Did I modify something here? What did I modify? Oh, yeah. But this is actually fixed. Okay, so I made a new release of React State, and all of this is actually part of a bigger plan. But let's just release it first. Yarn build. I don't trust the pre-publish script. Sometimes the pre-publish script doesn't finish before it actually releases, or something like that. Anyways, that shouldn't happen, but for some reason, yeah. I don't know. All right. Yeah, you see it builds it again. And it should build it like now it's done, and now it does the publishing. But sometimes it just doesn't contain the changes, and I have no idea why. Anyways, what are we going to do? Yes, we're going to look at the actual README, and I'll tell you a little bit about the changes. Let's see, let me blow this up. Okay, so React State is, like, the idea here was to really teach people about, well, a hidden message was state machines, but I hide it behind this explicit states term. And the reason is that people get scared when they hear about state machines, and it seems like this big thing, but it's at its core, like the fundamental thing of doing this is to change the way you write your reducer. That's the core of it. It's very, very simple stuff. And what's also difficult about it is to see how it helps you. So that is what this video tries to explain, like, why is this a good thing without talking state machines, just talking about the fundamentals. And then we have this reference project, which is called Excalibur Firebase. I'll make a video on that and create a README, because this is a project that any company who uses Google can use, where you basically get persisted Excaliburs. And its authentication model is based on the domain, like at Code Sandbox, it's on Code Sandbox.io. So anyone with Code Sandbox.io gets access to it. And we can see everybody's Excalibur. And I'm going to implement live sync there as well, which is easy, well, relatively easy to do with Firebase in the background. But anyways, that project has been a reference project for us internally at Code Sandbox as well, to explore an architecture on top of React, because we had to choose to continue with like some broad state management tool, or did we want to embrace React and rather create patterns on top of React to deal with the scale of things we are doing. And we went with the latter, and React State is a lot of the work that led to us feeling confident that we could do it that way. Let's see. And do I hear myself? I feel like I'm hearing an echo. Hello. I am. Where's that echo coming from? Hello. That's interesting. Anyways, yes. So version 4 has some breaking changes because I have a tendency to kind of abstract too fast. I'm prematurely abstracting. And the point of this whole thing is to just be these, where do we have that text? So React State is at its core 3 utility functions made up of 20 lines of code. Like that's the thing. You are going to consume React primitives and you're going to see those React primitives in your code. That's the important thing because it's a React architecture. And we're not hiding a bunch of implementation details because it's not necessary because it's very, very simple. So I removed the use states hook and that also was because there were some new patterns. For example, when you have context, you might have a nested context, which allows you to just use the helpers. It's kind of hard to explain in words why that's a thing, but you can have nested contexts, and then the use states hook doesn't really work. And also you might have subtyped context. So maybe you have 5 states on the context, and then you have a function that only deals with 3 of them. In that case, you also want to use the helper functions to operate on that subtyped context, and that wouldn't work. That with use states hook, you would have 2 different ways of operating on these contexts, which I didn't like. And now I also changed the transition, which you would call inside a reducer. It's now called transitions, and it creates a reducer. There's a couple of benefits that I'll talk about. Map is now called match because now you will actually import these helpers in your code. And map is you expect an array, maybe you use Lodash. Yeah, match is more like related to matching the state of the context. Funny thing, you had to add the DevTool manager. I have no idea why you had to do that, what my thinking was. You don't have to do that anymore. And also I've been exploring testing, and to this is a place where it's good to have a tiny abstraction because there was a bit of boilerplate code there. So that's also been fixed. Okay, so let's look at the actual solution here. Yeah, so you do explicitly import like transitions, exec, and match in this case. And you create your context, or type your context, you type your actions, and then you create the reducer. And now you can create this reducer outside of the component itself, which is a small optimization because it doesn't have to recreate this object every time. It creates it once. And it also keeps it enforces the idea that this reducer is pure. You can't like do any side effects or anything inside it. So this is how you create the reducer, and this also kind of makes it also very explicit about the explicit states. Like you shouldn't create your reducer using a switch. You should just use this function instead, and that creates an explicit guarded reducer for you. If you only did that, that would be a huge improvement in your code base. Yes, and the video explains why it's a good thing. Cool, and then we actually produce reducer here, or that's the thing I reflected on that. This is the reducer. This is not the reducer. This is like the hook result. They don't have a term for this in React, at least not in the typing. So I'm not sure what to call this array, but it's the result of the hook. So here we have the context where you typically just use the name of the thing you're implementing, and then you have the dispatcher. And then when you want to exec, you exec on the context. And when you match on the context. Cool. There we have the dev tools. It's the same. And then when you use it as a context provider, it's the same thing. And yeah, it's basically the same thing. So the patterns, like this is the thing, like when it's not really an API, surface, it you rather have patterns. And this is something I discovered lately. It's like I have always had this thing where developer experience is all about having these super simple API surfaces that kind of hides the complexity. But that is not really the case if you really understand the underlying tool. So to use React states and the architecture of this, which I'm going to talk a little bit more about, you really have to know React. Like, you have to know the primitives of React, how React works. But then you rather have these patterns that helps you like make your code more explicit and constrained. So yeah, so one pattern is like lifting actions. So when you create these, oh, this should be transitions. God damn it. Let me fix that right away. Transition. Wow, that wasn't very helpful. Lift. Well, fuck it. We'll do it later. You might have certain like handlers or certain actions that is going to be dealt with in multiple states. So the way you deal with that is that you move those up to, like, for example, global actions, and then you can implement them there instead, and then you just spread them out in whatever states it's going to deal with those actions. And to get the correct typing, you can use this pick action thing, which types this action to the specific one. Oh my god, there's so much crying downstairs. You know, I think that's the most exhausting thing, having kids. Like tiny kids, it's like the crying. I compare it to the mentors in Harry Potter. They kind of just suck the life energy out of you, and the reason it does that is because it's so exhausting. At the same time, you feel so bad because you're just not able to figure out why is the baby crying. Is it hungry? Is it tired? Does it have a stomach ache? And like, is it, yeah, whatever. And then, yeah. Then you kind of go for half an hour, then you try to give it food and it doesn't work. And then you try to calm it down for half an hour, and then it just doesn't stop. And then like half an hour later, like 1 hour later, you try to give food again. Like you remember that, oh shit, maybe like suddenly it's food. Like it starts with being tired, and then it's food, and then it's like overly tired, and then like it's a complete mess. Oh my god. Okay, and then match all the things. So you can match on more than the UI to produce like JSX. Maybe you want to create some specific CSS based on the context. You might even want to create like an object that you might want to create an object that kind of creates different properties that is going to be used to create your UI. But this object changes based on the state. As you can see here, it has a different icon, different text, and a different button style. But this allows you to express the button icon, the text, and the style in one go in the JSX, right? And related to this, I wanted to show you something. Let's see. Notifications. Okay, so I had this issue with a matcher. So in terms of typing, of course. So it's I created two different versions, where one version is extending the match. Like tmatch is just these states where it wants a function. That's tmatch. It's the keys are states, the values are functions, and then the second argument we pass in, like, where is it? The second argument, this object. This object is the thing. Like it extends, or that's the generic, sorry. Cool. And then we want to ensure that whatever we return from these functions becomes the type here. So in this case, the type here would be icon, which would be like a JSX thing or a React node or something. The text would be a string, and the button style would be an object of color string. That's inferred. That's really important. And then we have, but the problem with this one, as you can see here, is that, okay, this works. When I hover test, it does show me that the return type is number, but I can put, like, I only have the foo and the bar state here. So it doesn't yell at me when I add this state that doesn't exist, because it extends, right? It doesn't say it has to be t-match. It just says it has to be at least t-match. But that's a problem, because in your UI implementations, you might change these states, and then the UI doesn't yell at you when you have like stuff that doesn't need to be there. Anyways, and then there's the second one where we actually do make sure that we only use properties from the state. But if we do that, then it's unable to give us the correct return type. Then the return type becomes any or something. So how do we fix that? And I spent like, I guess, 2 hours or something on this. And the way to fix it is that you still extend it, but you give matches the generic it should be. But then you add a constraint on it. So it should be an extension of tmatch. And let's go through all the keys that you tried to add to matches. So this would be like foo, bar, and mip. And then we check, does this key actually extend the state? So in foo and bar, that's the case. Okay, in that case, just use whatever value is there. But if it doesn't extend the state, then give it never, which means that it shouldn't be there. And then TypeScript yells at you. And the return type works, which is great. But this is the big battle with TypeScript. But it's like I talked to my daughter. Well, she didn't ask me. I just tell her stuff. But she likes puzzles. Like, I guess puzzles can be many different things. But, you put these puzzle pieces together. And I told her that, like, my work is very much like that. It's just a very complex puzzle where the pieces are, well, abstract. And that's how it feels creating typing for TypeScript. It's just a very complex puzzle, and I've learned to appreciate it. It's fun doing it because I know there is some solution in there. Anyways, and then we have, so this was partly the reason why useStatesHook is gone. It's because you might have a function that only operates on, in this case, A and B state. So you want to match on that specific subtype of the context. And then I discovered something, and this is base context. Like, you might have multiple states having the same values in this example IDs. So this is a very explicit and readable way to express that. And then we have nested contexts, which is new. Well, it's not new. Like, I just discovered it as a pattern looking at the XState catalog examples. And that is, you don't necessarily only have to have a root context. You can actually add, in this case, I'm adding a validation context to the active state. And this is really interesting because this means that we're actually leaning into the powers that state charts gives you. Like, it's not the same as a state chart. It's not like declarative, and there are certain things you can't do. It's maybe the wrong term, but like one thing you don't really have in this concept, you don't have, well, you kind of do. Well, I guess, so one thing you don't have in this concept is that you aren't able to express a state, and whenever you enter that state, you do something to the context. Like, the context can only change through an action dispatch. There's no concept of, okay, whenever I enter foo, do this to the context. Because it's driven by the actions. It's always when this action occurs, do this. And many actions might lead to foo, for example. I hope that made sense. But anyways, what we do get is this nested context. So the way you would use this now is that, okay, so you want to trigger an effect whenever we move into pending validation. Well, then you can exec on the root context. When it's active, we grab validation and then we exec on that validation, because that's also just the context. And then we run the effect on pending. So that's really interesting. And the same for match. You want to display something in the UI related to the states of validation. Well, when it's disabled, the root is disabled. I want to do this because this is exhaustive. You have to define everything. When it's active, focus shouldn't be there. We grab validation and we just match on that and then return that. So it's really interesting how you can do this nesting, and you can do it in parallel as well, which is also part of like state charts. So it's pretty cool how we can do this. And in the Excalidraw, it actually, the clipboard functionality, if you have put something in the clipboard or not, that's actually a nested context. Like it has the state copied or not copied. Instead of the root having like an edit, dirty, and copied state. Like it doesn't need to be there on the root. It just kind of explodes the state. Anyway, so the API now is transitions. Wow, I'm in lack of time. So this is where if you only use this in your React code base, it will be way more explicit and constrained. So that's something to think about. It basically just creates a reducer, a better reducer. And blah, 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 exec, match. Yeah, and then we have result. Shit, I should have had more time for this. So error handling in JavaScript is sucky, especially when you do TypeScript on top, because you don't get typed errors. When you do a try catch, you never know the type of the error, what kind of error it is. Is it related to the JavaScript runtime? Is it related to the side effect I'm trying something around? Have I covered all the errors that I should cover? Like, it's just really, really sucky. So there's a concept in Rust called result, and there is implementations of this in TypeScript, but it's big. Like the surface is too big to be used on its own. I think it would be very confusing. But more importantly, we want cancellation. So we want you, whenever there's an effect, we want you to return a result instead of a promise. And the result is basically a wrapped promise, but it never throws. It never throws. It only returns OKs and errors, which means that you, as you can see here, when we resolve the result of the result, you have one callback which takes in the OKs, and then you have an object that takes in the different errors. And this is exhaustive. You have to define all the errors that this side effect can throw. And the cool thing is that if you were to cancel it, it won't run any of this. There's an optional error of cancelled. So you can add cancelled here, but you don't have to. But that would actually run if you were to cancel it. So that means that you don't really have to deal with cancellation specifically related to fetch or whatever else. It's a generic cancellation around the promise, because you don't really want to cancel the HTTP request. Like that sounds a bit silly. Like what if you do a post and you just cancel it? And what does the server do when you cancel it? And yeah, it feels better to just cancel further execution. So it finishes the last thing it did, but you have said that don't move on with the logic from here. Anyways, and then we have the render reducer hook, and this is inspired by like the React testing library, where you have render, which allows you to render JSX, and then you have render hook, which only allows you to like use some hook and then test the result of it. But we need something in between. We need to render the hook, but then we need to be able to put, and what happens under the hood is that it creates a component out of it. This is the same for render hook in React testing library. It creates a component around it, which accesses the result of the hook. But we want to insert that component in a render tree. So in this case, we have a context provider, and we need to insert that hook component as a child of that context provider, or you wouldn't be able to test the result of the hook, right? Because it depends on the context. And what this allows you to do is to, you just get to reduce the result back here, and then you can test it. And what's insanely interesting about this is that this context object, it's actually an object that's created when you create a test. It's not the object that's actually returned from the reducer itself that you're testing. What it does is that whenever the hook updates, it deletes the keys of this context object and then adds the keys from the updated context returned by the actual reducer. And what that allows us to do is to reference the same context and do testing on it. And you will always have an updated context. So if we use the context actually returned from the reducer, then this wouldn't update. You would always have the old one. So I really, it's hacky, but it's for like having good tests without blowing up with. I think that's more predictable and certainly more enjoyable than having boilerplate where you might do something wrong. Anyways, just a quick end to this. I'm writing a Git book on an actual application architecture on top of this. Let's see. And this is what we're currently developing in Code Sandbox. It's the application architecture that uses these things. And the Excalidraw project is a reference project for us. So any change we make to React states and how we think about the architecture, that is updated in this reference project to kind of try it out and test it. But it's like still in development, the architecture itself, but we do try to update the documentation for this. And that is also what leads into this book thing. So when we actually have something running on this architecture, I really want to write a book about it. Because it's extensive, right? It's not just an API documentation, it's how you conceptually think about React and building complex applications on top of it, like general things in programming around explicitness and constraints. And there's a lot of mental models here, like you have the environment application is running in, how do you create an interface between that? Like there's so many things. And I think it's worth a book. Yes. Anyway, so that's the plan. Please test it. Ask me any questions. I'll keep you posted on the progress of this. But tomorrow, I want to try to implement the Excalidraw sync thing. I'm really excited about getting that, like the live collaboration thing. Because Excalidraw has this function called update scene, and I believe it just takes one scene and then merges it into the new scene, because every element in the scene has a notion of what version it is and stuff. So I hope that that's the thing we need to do. So whenever we update in Firebase, we use update scene to get the new scene. So we can use a transaction on that, And then we do the same when you receive an update. We check, has the version changed? And if the version has changed, we update the scene in the client. And I think that will just work. That's the idea, at least. Okay, cool. I have to go into a meeting, but we'll talk later. Bye for now.